This is part 2 of section 6.4 and 6.5. Get the same base. Again, a box for you to write down any extra notes you may want to. So example 2, solve the following equations. Now here we're going to have two exponentials or two logarithms. And what's really nice is when you can have the same base. So for example, in part A, they already have the same base, 117. So then you just 117 it up on both sides. It cancels out the logs on both sides, so we get 1 minus 3x equals x squared minus 3. Now we have a quadratic equation. So to solve a quadratic equation, you want to get all the terms on the same side. So we get 0 equals x squared plus 3x minus 4. And then factor it. So 0 equals x plus 4, x minus 1. Set each factor equal to 0, so x plus 4 equals 0, or x minus 1 equals 0. So we get x equals negative 4, or x equals 1. Now, like I said before, you do have to check these. And it's not that you have to check and make sure the answers are correct, but check and make sure that you don't get an undefined part. So when we plug negative 4 in, well, we get 1 minus 3 times negative 4, which is 1 plus 12, which is 13. Or we get negative 4 squared minus 3, which is 16 minus 3, which is 13. So the 4 does check out. Now for the 1, well, we get 1 minus 3 times 1, which is 1 minus 3, which is negative 2. And since we can't take the log of a negative, that is not allowed. So x equals 1 is not a solution. And we actually only have one solution to this logarithmic equation, and it is x equals negative 4. Now in part B, again, we've got two exponential expressions. We're going to try to rewrite it with the same base. And the same base we're going to shoot for here is 2, because 16 is 2 to the 4th. Now don't forget, the 2 to the 4th only replaces the 16. We still have 1 minus x. So we get 2 to the 3x equals, and when you have a power to a power, you multiply. So that would be 4 minus 4x. And now since the bases match, we can take log base 2 of both sides. That'll cancel out the 2's, and we're left with 3x equals 4 minus 4x. Add 4x, add 4x. 7x equals 4. Divide by 7, divide by 7. X equals 4/7. And if you plug that in, it will work out. Part C. Now this one's a little bit more tricky to think about because we have this 9 times 3, so that's not even an exponential. But if you think for a little bit, I hope you realize that 9 is the same thing as 3 squared. And then when you're multiplying like bases, that's the same thing as adding the exponents, so 3 to the 2x. Well, unfortunately, unlike in part B, we won't be able to make the 3 into a 7 or the 7 into a 3 using exponents. You could use your change of base formula from the previous section, or I'm just going to take log base 3 of both sides. Now on the left-hand side, the log base 3's cancel out, so we're left with 2 plus x. But on the right-hand side, we're going to actually have to use our log property because this is log of an exponential. We can drop that 2x down. So we get 2 plus x equals 2x times log base 3 of 7. Now the highest exponent, the x's are 1s, so this is actually a linear equation, even though there's a log in there. But because this log only has numbers, it is just a number, it's just not a nice number. So since it's linear, I'm going to get the x's all on the same side. So we get 2 equals 2x times log 3 of 7 minus x. I can factor an x out of that, which is 2 log 3 of 7 minus 1, and then divide by 2 log 3 of 7 minus 1. So we get x equals 2 over 2 log base 3 of 7 minus 1. And that's it for part 2 of the notes.